Let's talk about B cells first. The type of immunity produced by B cells is more appropriately called humoral immunity. It starts off with one of these. Yes. A nice little, sure, it could be a macrophage, it could be a dendritic cell. Its big name is antigen presenting cell. It takes in the bad guy. It tears him apart. And it displays, somewhere on its surface, the little antigenic determinant. On what kind of MHC? Are you sure? It's an MHC2 because it's an antigen presenting cell. Okay? Right? Antigen presenting cells, mostly MHC2s. It's all body cells that have the MHC1, but antigen presenters specifically have MHC2s. Right? Because we're not trying to kill this antigen presenter, are we? We're trying to go out and kill the bad guys wherever they are. So look, a helper T cell comes over. Oh, the helper T might be bigger. I just draw him like, he looks like a little cute baby. It's a helper T cell. Now, we'll add a little piece of the picture. This little way that the helper T links up, it gives the helper T another name because they call that little linker protein a CD marker. They call it a CD4. CD stands for cluster of differentiation. I don't think you want to memorize that. Okay, so we'll just call it CD4. So sometimes they call helper T cells CD4 cells. Just another name for them. Our book talks about it a lot. That's why I'm mentioning it to you. Do helper Ts kill things? No. What do? They work to stimulate the rest of the immune response, specific immunity, by releasing chemicals called blank. Very good. Cytokines. Here they are. Many different cytokines. We're not getting all into that. If you ever take immunology, you'll have a blast with it. Now, these cytokines can activate a B cell. And when they activate a B cell, that B cell will only be capable of fighting against what? That one particular or specific AD. Right? That's it. Can that one specific particular AD be on 20 billion cells? Yes. It can be 20 billion bacteria in your body. As long as they're that same one with that same AD, this particular B cell can fight it. What if it's a different bacterium or a different surface marker? Will this B cell be able to fight in any way? No, it would have to have a whole other separate population of B cells prepared to do that. Okay, so this B cell, those cytokines get over there. And remember, most of the time we say that this B cell has already had a prior contact with what? The antigen. Could we say the AD instead of antigen? Sure we could. We could say that. So this B cell's ready. The cytokine hits it. The B cell is now active. Here's new information. We haven't talked about this. The B cell will clone itself, a huge population of clones. So they rapidly divide. Notice how I'm kind of separating them out here. Most of these B cells will get a new name. And they will get the name plasma cells. And those plasma cells will do this. What is that? That is an antibody. These plasma cells will crank out antibodies. at the rate of 2,000 per second. An active plasma cell, can produce 2,000 antibodies a second. That's 4,000 in 2 seconds. That's 120,000 in a minute. Every minute. How many is that in an hour? A lot. Wow. 7.2 million. It's crazy numbers. It's a lot. Every hour, it keeps crunching them out. What do these antibodies go do? They go find an AD and bind to it. And we haven't talked about how they work yet. I'm going to get to that rather quickly. Look, when we cloned these and went through clonal selection, remember that word from last night? Clonal selection. S-E-L-E-C-T-I-O-N. This is supposed to be an A right here. Some of them become plasma cells, and what are these over here? These are memory cells. Memory cells are not capable of making antibodies yet. What's a word that means they can't make them yet? Pardon? Not a fancy word we learned tonight. It's just a word that means they have to sit there and not do anything for a while. They lie dormant. They're dormant. They're inactive for a while. Usually it's a few months. There's not an exact number of hours, but they are inactive for a while. And the only thing that those memory cells can ever respond to would be what? That one specific antigen. Could you ever meet up with that one specific antigen later in your life? Yes. If that bacterial strain comes through again and people get sick with that same thing later in life, you bet it can come through again. And this person later in life would be protected from that. See, when memory cells get stimulated later on, they produce a larger response and a quicker response. Much larger and much quicker. In fact, the first time you meet a new antigenic determinant and you go through the B cell response and you make antibodies, it takes 7 to 10 days to really combat that. They call this a primary immune response. That's the very first time that you've ever met that bad guy. And in a primary immune response, you will actually get sick. Because the bacterial population or whatever will grow fast enough that you get sick, then your plasma cells start kicking in after some time, and about 7 days in they reach maximum, and it starts to fight it, and then it's over. Usually. But with a secondary immune response, we'll just put IR for immune response, that's quicker. In just a few days. It could even be 1 to 2 days. They reach maximum intensity of production of antibodies that quickly. And so commonly, with a secondary immune response, a person might get just a little bit of sniffle or just a little teeny bit of a sore throat, and they never really get sick. You're like, oh, I thought I was getting sick, but I didn't get sick, and I'm better. That's because the secondary immune response is faster and it kicks in, right? And it used memory cells. Well, if it's a secondary immune response, are you going to use all the memory cells, or are you going to save some of them for a third time? You're going to save some, but guess what? The third time you'd still call it secondary. The fourth time you'd still call it secondary. The fifth time, the 100th time, it's still secondary. So remember, when memory cells get activated, they won't all get activated. Some of them will become what cells? What are the active ones called? Plasma cells. And some of them will stay memory cells.